Welcome back to GoldwingDocs. I'm Scott. This is episode 7. You got questions, we got answers coming up next. As I mentioned previously, we got a ton of questions the last time I asked. If you have questions you want answered about your Goldwing, add them into the comments below. We read all the comments and we'll definitely pick them up and answer them in a future video. All right, let's get to them. Cloud Siragusa, I don't even know why I try to read these. My 98 1500 lost the sound, air ride, and CB. I changed fuses, but still nothing, blank screens on all. What causes that? All right, well, electrical questions, I love electrical questions because they're really easy, usually to track down. When you look at something like this, when you have several things that fail all at once, you basically want to go back to trying to figure out what is the common factor in all these things. And in this case, the common factor is the accessory circuit. So you said you changed the fuse. Now there's two fuses, kind of two fuses that might be involved here. The first one is fuse 10, which is in the main fuse box. That's your accessory fuse. That powers the suspension, radio, and CB, among other things. The other one is fuse 13. That one's actually in the relay box off to the side. That is a battery backup fuse that powers the radio, the clock, and the CB, and it's what lets it keep the memory. So it memorizes the FM radio stations, keeps your clock running when the bike is turned off. Even though that's all it's used for, especially the radio and the clock can actually malfunction if that fuse is blown. On the 1800, if that fuse blows, the radio will work, but it'll play really quietly. So you get odd results when that backup fuse blows. So check both of those fuses. The air suspension system does not use that backup fuse. However, I suspect that maybe the reason your air pressure isn't working is because the screen isn't working, and that may depend on that ACC fuse, but we'll assume that those two fuses are okay. The other thing that it could be caused by is the ignition switch. The ignition switch has several different contacts in there. It's got ignition, accessory, and park. The park is when you turn the key backwards and you lock the handlebars and the parking lights come on. That's the only time that actually gets used. If you turn the key part way to accessory, only the accessory circuit energizes. If you turn it all the way to on, now both the accessory and ignition circuit are energized. So if the switch itself, the contacts have worn away, it's possible that the accessory pad is not making contact in either of those two positions. So check and see if your accessories, such as radio and CB and so on, come on in either of the key positions, in either accessory or on. And if it comes on in one but not the other, then maybe that's your switch that's caused that problem. If it still doesn't come on in either of those, then perhaps we have a problem with a cable coming out of the ignition switch, one of those wires that runs into the fuse block that powers everything else. There is one other thing that you can check, and that is the accessory terminal on your fuse block. It's that little screw that allows you to attach other accessories onto your motorcycle. That fuse actually gets powered by the same switch, but it actually has its own fuse. It doesn't run through the regular accessory fuse number 10. So if you turn your ignition on and you have power at the accessory terminal, but not power at all the stuff run off the regular accessories like your radio and CB, then you know your switch is okay, and the problem is perhaps either with the fuse or a wire on that accessory circuit itself. And I'm not saying that this is your problem, however, it is not outside the realm of possibility that you have a bad relay. The contacts in the relays do wear out. Sometimes they will pit in a way that they can only pass a certain amount of current. Sometimes they just fail entirely. The relays in your bike are electrical mechanical devices. They do have a limited life. They will wear out. So you might want to check out the relays as well. I encourage you and every 1500 owner to go to the GoldwingDocs website and at least pick up 1 or 2 or 3 spare relays, because these things do fail and you really don't want to be stranded. I'll put a link to it down below. So hopefully that's of assistance. It gets you a little farther down the road. If you still have problems, definitely come onto the GoldwingDocs forum and post your question, because we've got lots of electrical experts on there that can help you diagnose and trace down this problem. Okay, next we have Alan Heinrichs. Thank you for a simple name that I can read. I recently had to replace my fuel pump on my 92 1500. I thought I marked the 3 plugs, 1, 2, 3, with number 1 being ground, but the other 2 Sharpie marks are rubbed off. I can't remember which one is which. Will it smoke something if I have those 2 backwards and turn on the key? I would have probably found it the hard way if I had the key. I'll wait for an answer before I get back to it. The answer is yes. You will probably smoke something if you swap those two. Those 2 connectors, one of them is for the fuel pump and the other one is for the thermistor that turns on your low fuel light when you have low fuel. The problem is that thermistor is just a resistor, and if it is at low resistance and you have them swapped backwards, it will end up sending fuel pump voltage and current, more importantly, into that thermistor. Not only can it cook the thermistor, but it could also cook the output of your ECU that drives that fuel pump, because it'll be drawing too much current. That's really bad and kind of expensive to fix, so don't do that. If you have a look on the top of the fuel pump module on the top of the gas tank, you'll see there's 2 terminals on there. There's one that's a ground that's you can tell it's welded right to the metal of the thing, and then there's 2 insulated terminals. And if you look closely, there's a little stamp, a letter next to each one. One is B, one is W. So the B is the fuel pump. And that one, the wire going to it is black with a blue stripe on it. And the thermistor, the low fuel light, is the W terminal. That's the yellow wire with a white stripe on it. So that should get you plugged in correctly and get you on your way down to getting your bike running and riding in this miserable snowy weather we've got today. Okay, third question. Terry Boyle, another readable name. Are the charging systems for our Goldwings suitable for a lithium-ion battery? Is the voltage and amperage in the design operating envelope for them, or is the voltage or amperage too high? Lead-acid batteries have been around forever. They started out with wet cells, and now we have AGMs, and if you have a Goldwing, you should probably be running an AGM, not a wet cell. And those batteries are well suited for this type of application. They do have their limitations. They don't like cold weather. They don't like really hot weather. They don't like being drawn down too low. They can sulfate the plates on them, and they're heavy. They're really heavy. Lithium batteries are way more expensive, they're much lighter, and they have some other benefits as well. So let's talk about pros and cons about lithium batteries. Lithium batteries, they work at 13.2 volts, whereas a lead acid battery, I think it's 12.2, 12.4 if it's just fully charged. So by default, you have a higher voltage. Now your bike will run fine at 13.2. In fact, when the engine's running, it's at 13.8. So that's fine. Lithium battery will power the bike, and it will actually run better on a lithium battery than your lead acid battery because the volts are higher. So your lights will be brighter, the radio will be louder, the engine will start faster, quicker, because you've got more power going into it. Remember, power is volts times amps. Amps is determined by the resistance being in the load, which is constant because the starter doesn't change. So if we have volts times amps, amps doesn't change, but volts goes up, that means power being delivered to the starter goes up, which means it spins the starter faster, your bike starts faster. So yes, lithium batteries will start your bike better. Lithium batteries have a higher power density. So what does that mean? It means it crams more energy into a smaller area and lighter area, more importantly. So that's why you have your cell phone with a massive 4 amp hour battery in it that you can hold in your hand, that years ago you would be walking around like an old bag phone, and you'd have a heavy lead acid battery in there that would be required to provide that type of energy. Because the energy density on lithium batteries are so much higher, you can have a much smaller battery providing the same amount of energy. On a motorcycle, we don't really care if the battery's smaller, so if you can put the same size battery in there, but it has way more energy in there, that means you're gonna have a lot more reserve in that battery. Lithium batteries have a more stable voltage. So if you start using a lead acid battery, it kind of starts tapering off as you use up the power stored in it. And as it tapers off, the voltage drops. Lithium batteries are different. Lithium batteries have pretty much a more or less stable, consistent, constant voltage until they get to the point where they're almost empty, and then it just kind of falls off a cliff. During that time, you have lots of power the whole time, whereas in a lead acid battery, you're going to start seeing the lights start to dim over time, and the bike's going to start running poorer and poorer. And whereas a lithium battery, it's going to be nice and bright, everything's going to be great until it's not. Is that a benefit? There's pros and cons. If you're riding along and you lose your alternator, now your bike's running off your battery. A lead acid battery will run, and then as it starts getting down, you're going to notice the lights getting dimmer, and then the bike's going to start misfiring because it doesn't have enough power to fire the plugs, and then it'll die. So you'll have a little bit of a warning before it actually dies. Lithium batteries, you're going to go way longer because you remember you've got all that extra storage in there. So the bike's going to run off the battery without the alternator for a much longer time. However, when it does die, it's going to die all at once. You're going to be right along, and it's just going to go from full power to nothing. And now you're dead. Now you're stranded. So yes, lithium battery is going to get you farther if you lose your alternator, but you're not going to have warning when it dies. Lithium batteries can put out a ton of current, an absolute ton of current. So can lead acid batteries. They put out a lot of current, but boy, lithium batteries can just put out so much current because they have low internal resistance. And that's why you see lithium batteries that just blow up, because if there's a short inside, the amount of current that's going because of that low resistance just creates so much heat internally of the lithium battery, it just blows apart. So yes, you get lots of current. That's really great because the more current you can supply, the better the engine's going to start. And they're lighter. I did mention that. All right, so let's talk about some cons. They're definitely more expensive. There's just no getting around it. Lithium batteries cost more to make. They have exotic materials in them that are mined from far off places, including Russia, so they're going to get a lot more expensive soon. And lead is everywhere, and not only that, lead acid batteries, they can take the lead out of them and reuse that lead. That's why you get a core rebate when you trade in your old battery, because they can just pull the lead out of it and use it in new batteries. Lithium-ion batteries really don't work well in the cold. Neither do lead acid batteries, but lithium batteries really don't like the cold. You get a lot less current available in a lead acid battery when it's cold. That's why they call it CCA. If you look at the rating of a battery, CCA is cold cranking amps. That means how much current can it supply at a specific temperature, which is, I don't remember what it is, but it's cold. Lithium batteries put out almost nothing if they're really cold, not enough to even start your bike. So if you're parked overnight somewhere outside next to a hotel and it gets down below freezing, you come out and you're going to start your bike, it's not going to start. Doesn't mean you're stranded, it just means the lithium battery can't provide enough current to actually crank the bike. However, it can create enough current to run the headlights and other accessories on the bike. So what you have to do is turn on the bike, let it sit for a few minutes. Now that the bike is on and current's being drawn, to run the headlights and the various systems, it's actually pulling current from that lithium battery, and it's actually moving it through the higher resistance inside that's caused by the cold. And moving current through resistance generates heat. So as you draw current from the battery, you're actually heating up the battery internally. If you let it do that for a few minutes, the battery gets warm enough inside that it can now provide full current in order to start the bike. So yes, it's a downside, but as long as you give yourself a few minutes in the morning on a cold day to condition the battery and get it warmed up, you shouldn't have a problem. Lithium batteries are dangerous to jumpstart. You should never jumpstart a lithium battery from a running vehicle. It can put so much current into a lithium battery, you can actually cause it to explode. And lithium battery explosions are violent, and it's not just a little spark and a pop. You've seen pictures of electric cars burning down and huge explosions. You don't want lithium batteries to explode. You can jump it from a battery, so like a battery pack, clip it on, let it transfer some of the energy into the lithium battery, start the bike. So you can do that, but never ever jump it from a running vehicle. The last thing about lithium batteries is because the resting voltage is 13.2 volts rather than 12.4 or whatever it is for lead acid, you can't use a standard smart battery charger, such as a battery tender, because those battery tenders will see the resting voltage of the lithium battery as an overcharge because they're expecting to be connected to a lead acid battery. And that means they will never actually engage themselves, they'll never charge the battery. But you can buy lithium specific smart chargers or smart chargers that have a switch that allow you to change from lithium to lead acid. A battery tender makes one of those. I'll put a link to both the regular battery tender and the lithium battery tender in the description below. And I really recommend you have a battery tender on your bike. My bike is plugged into the battery tender 24/7 when it's not being ridden. And as a result, my batteries last 8, 9, 10 years because the battery is continually being topped up. And this is not a float charger, it's a smart charger. You definitely don't want to plug in a constant float charge into it, that'll destroy your battery. But a battery tender, like a battery tender junior, it's $30, $40, will save you hundreds in costs of battery. So I'll definitely click on the link below in the description and get yourself one of those. And that's it for this video. I hope you liked what you saw. If you did, please click like, then click subscribe and that little bell. It really helps us out when you do that, and you get notified whenever we post one of these fantastic videos. Plus, don't forget to check out the GoldwingDocs forum. We've got so many articles on how to do all kinds of different things onto your bike, DIY articles, friendly help, lots of people. We have 90,000 members there. They're so friendly, nice people. If you have any questions, any problems at all, they are more than willing to help. Thanks for watching.